Yes, hello everybody officially, and welcome to the new Nordic-RSE seminar series talk. Before we give the floor to our speaker, let's have a short housekeeping round. So during the talk, we will mainly use this HackMD file for interaction. I'm now again posting the link in the chat. And this HackMD has some general information about what is Nordic-RSE and what is this seminar series if you're new, and this is the first time for you. So Nordic-RSE is this association based in the Nordics to bring together, support, and offer networking opportunities to researchers, software engineers or people interested in such. And one activity that we have to offer networking and learn new skills is this seminar series. So you can find the link to the seminar series here in the HackMD. We have been having talks since August. This is the fourth one. And if you have something interesting that you would like to share, some tool that you have been developed or some workflow that you have that you think it's so useful and would like to share to others, then that would be fantastic. We would be very happy to have you as a speaker. You can contact us in the Code Refinery chat. So here you can also find the link to the Code Refinery chat. You can join to contact us, and you can watch the previous talk from YouTube. So we have this YouTube channel where you can find the previous talks if you missed them. We have this seminar series playlist. Yes, and if you want to join Nordic-RSE, that's also fantastic. You can also find the link to the membership form that you can fill to join us. That being said, our speaker today is Frankie Robertson, who is doctoral researcher from the University of Jyväskylä, and his research is mainly focused on natural language processing and how to exploit background knowledge, such as massive corpora. And he's also enthusiastic in making data munging more reproducible. So he will share today some tips and tricks about that with us. And in the HackMD, you will also find the short abstract and a longer abstract about the talk. And in top of the document, there's this link to the material. I can also copy paste in the chat if you want to follow during the talk. And finally, at the end of the document, there's this ask questions here session where you can ask questions if you would like. And you are also welcome to unmute yourself and speak up if you have questions to ask. Otherwise, you can write in the HackMD and I will be DJing to Frankie the questions. So that's all from my side. And Frankie, the floor is yours.
Okay, now I can share my screen. Oh, yeah, I can. Can I?
You cannot?
I can, just where it's set. Yeah, okay.
Yeah.
There we go. Okay, so to start off with, I've got a few slides just to motivate some of this stuff. Luca already introduced me. So I've been doing quite a lot of pipeline-oriented batch processing in my work. I'm first going to talk a bit about Singularity and HPC in general and SLURM and Snakemake, and give a little bit of, explain a little bit what a snake file looks like, so how to write workflows in Snakeflake, and try and give some tips for effective usage of these tools. And then I'm going to go through a bit of an essentialized version of a video processing pipeline, and also try and run it. It's a mini version. Try and run it on CSC for you. So this is a bit loosely planned, looser planned than I was trying to start off with, and it's a little bit more focused than what I talked about in the abstract. So for that reason, like, just interrupt and ask questions, and we can make it better that way, by making it more interactive. And also afterwards, if you think of something afterwards, then correspondence is welcome. Afterwards, you can email me and I'll Zulip up or GitHub issues on the relevant repositories or ways to reach me. So here I'm kind of distinguishing reproducibility and repeatability. So containers really kind of help with repeatability. repeatability is really running the exact same code on the exact same data to get the exact same results or as close as possible, whereas reproducibility is perhaps more desirable in some way, that we're actually describing things and it could be reproduced with like different tools later on. I mean, the tools we're using can change over like 10, 20 years. So you want something to last for a long time, then describing it's the best way probably. But maybe in a limited sense, having repeatability does help with reproducibility, because there can always be bits missed out or misleading in a publication. And at least you have something to kind of, something that is known working to reverse engineer. So I think it's a good extra thing to have to distribute and archive containers if possible, although there are difficulties that come with that. So like how can we get our software onto HPC? This is the kind of other side of containerization. It's a convenient way to get your software running on HPC, or it might be the least inconvenient way, at least. So the kind of old school approach to HPC environments is you might ask an admin to install the software, which the HPC admin, which you then load as a module, for example. It might need to be reasonably popular and ask nicely and wait, and it's duplication of effort. Everyone has to do this on a cluster, and this is like almost definitely not repeatable. I mean, if you have certain flags that you build stuff with, I mean, this is really like not transparent for people outside of your organization. So you can compile it yourself. You better document the process at least if you want any repeatability. Or you can use, I mean, a pretty nice alternative to using containers really is to use, if everything is that you want is in something like Conda, then this could be a pretty good alternative, I think. But everything has to be a Conda package, and there's the temptation to start hacking at your environment, and then it's no longer repeatable. So what always works is the lowest common denominator really is using container, and the runtime we have access to in HPC environments usually is Singularity, and I think it's actually once you get used to it, quite nice for doing stuff in HPC. The image format's a single file. It can be archived and distributed for repeatability. You can move it to fast disk space. It's got good defaults, so it binds your home and working directory. So usually the stuff that you want from the host is just there in the right place. And it's kind of convenient that it sort of blurs. It containerizes and then it uncontainerizes a bit. It kind of blurs the host because you need stuff from the host. You can't really, like, typically you're not going to have all your data in your container. You could do, but you might have really massive data, and this might be impossible. But, so it can help with repeatability, but it's not necessarily a panacea because you have to leave your data out of the image and people have to get that somehow. And obviously, like in the future, it could be a completely different computing resources we have available. So then maybe we can't even run it anymore. But I think it can help. So I would defend containers and say they're part of the solution. So onto Snakemake. This is a make-like tool, as the name suggests, and it was written within the context of bioinformatics. But actually, it's you don't need to, you can use it for lots of things. You don't need to. You can use it almost anywhere as long as you meet the basic assumptions of you like to use files, and you know you can start to write stuff with kind of implicit parallelism in your rules. You can write kind of scatter gather or map reduce type rules just using kind of file names, using wildcards and file names. So it's really not tied to bioinformatics. You can really use it for anything, subject to some things. So it is a bit hairy. So we're mixing 3 languages typically in a snake file. We've got kind of Python going on, and then we've got special Snakemake directives. And then often we also have shell in there too, a bit of bash in there too. But if you're willing to kind of like hold on and hold on through that hairiness, it has a lot of nice features too. So you can do partial runs of things and then resume the partial runs. And if you have a long workflow that would take several days to do the whole workflow, if you have a problem halfway through, if you find you have a bug that happened halfway through that workflow, then you can fix it halfway through, and you only need to rerun the latter half of your pipeline, which can be very useful. And then there's this implicit parallelism, and you can combine multiple languages without having to use any foreign function interfaces or anything like that. You just use like neutral file formats, and it also scales down as well. As you can run it in a cluster, but you can also scale it down to just run it using it as a make replacement for like small pre-processing jobs on your laptop. And I think it's a good choice, but you have to be like willing to take the penalty of like serializing and deserializing to files. That's clearly the like downside. Like every time you're checkpointing between different steps, you have to put it into a file and take your stuff out of a file. So obviously that means it can't work for everything, because some intermediate steps might produce more data than you have storage, for example, and then you have to use something else, like you have to do something streaming and not with files. But it's a useful tool in a toolkit, I think, for a lot of things. So, and then we have SLURM. We all recognize SLURM as our batch job scheduler. I think it's probably the most common one, although there are still others in some HPC environments. So, I mean, I've kind of had access to maybe 4 HPC environments, one in the US, one in the UK, the national one in Finland, and just one at my university here in Jyväskylä, and they all use SLURM. So I think it's pretty commonplace. And the typical way you use this is you have SLURM directives at the top specifying the resources you want, and then you have a bash script and you submit this with the sbatch command. But then there are higher level tools built on this that's maybe try and template this or template the script usage or making these sbatch files. And so SLURM's kind of fine, and it has nice high level tools, but maybe it's nice to be able to also use things that work in terms of SLURM and things that aren't dependent upon SLURM and can work with SLURM or other systems like Snakemake, for example. So now I'm going to go on to some tips, and I'm going to start to like look at some code at the same time. What I found with Singularity is they have these things called Singularity definition files. When you build your container, you can have a Singularity file, right? Which is made up of steps. It looks a lot like a Docker file, but this is not really supported anywhere now. There used to be this thing called Singularity Hub. You could use them to as a kind of continuous integration thing. But now you have to build them. Well, often you would have to build them on your own laptop if you use this, because you need root to build the Singularity image. So you need to download and install Singularity yourself, and then that's a bit of a palaver. And also it doesn't work with any kind of continuous integration thing. So because like Docker files are kind of supported everywhere and OCI images are supported everywhere, I would recommend to use this instead. And then what Singularity can do is it can convert these. So where are we? So here's a Docker file, which this is based on a project I made for some gesture researchers called Scale Shop. And this is just extending that Docker file a little bit for the purposes of this demonstration. So all I'm actually doing is putting in a snake file. So here's here's where it extends. Let me bang out the font size a bit. Whoops. All right. Here's where we extend Scale Shop. And then we copy in some things that we're going to use in the workflow. And then we add this workflow directory, including the snake file, which we will look at later. And then we also install YouTube DL into the container. And then this is taking some startup stuff from that's for Docker and making sure that it always gets loaded for Singularity. So you can make sure scripts get run at startup in Singularity here. So sometimes you have to do like stuff like that to get stuff to work both on Docker and Singularity. But once you go through that, then you can, for example, GitHub, you can just go, and what I would do is I would just copy paste in all this boilerplate GitHub Actions stuff. Yeah, I mean, I really just copy paste it in and then say like at the end, like here, yeah, here, put the image here, and then you just make sure this file is here, and then it's going to build it for you, which is nice. And then, yeah, you get your package. Just here, and then it tells you how to pull it with Docker, but instead you're going to pull it with Singularity. So, and that's what I've done here, except that. So I would go Singularity, pull, and then the SIF name. And then you just say the magic word, you put the Docker protocol on that, and you can pull any Docker image. So this is, I would say, the most convenient way, and the way that like doesn't tie you too much to Singularity too, because you can also distribute Docker containers if you want to use it. It's somewhere other than HPC. Okay, so next thing. Yeah, Singularity actually lets you do run straight from Docker, but I would say this is kind of like more or less a foot gun, because what happens? Okay, if you say you run this on a cluster, say you run this in a SLURM array job, you make your own SLURM array job, and you have this Singularity run, it's going to pull on each node separately. So it's actually better to, even though it's like a bit less convenience, it's better to convert it once and avoid that. This conversion process is unfortunately a bit slow. So this is the downside to this this approach, but this way you avoid tying up the whole cluster, just converting your image. So yeah, and I tend to do that on the login node, which I think it's okay. So other things is this, when you use Singularity, this should be a tilde here. I messed up putting a tilde there. So find somewhere big for your Singularity directory, because everything gets cached here. So you might have to put this in some slow storage, unfortunately. But often in HPC you don't have like a massive home directory, right? So you move this somewhere else and symlink it into your home directory. And then my final tip is that you should cut down on rebuilds by using binds. So if you just change a few files, you should just maybe bind in the directory that has your actual code in, but then kind of include it in your image, but then bind over it. Singularity lets you do that, and that works quite well. And then you can use tools like lsyncd. So I'll show you exactly how I do that. So I would have this lsyncd, and I would pass some random things to it. In fact, normally I wouldn't add this, but I will just add it to a repository just because, just in case you can't see this. So we had this lsyncd command, and then you can code on your laptop. It will run this in the background. It will keep syncing it, and then you can when you're hacking and testing, you can also bind the same thing. And I think this is a reasonably productive workflow if you can't run it on your laptop, if you have to run it in HPC, or at least that's what I do. Interested to hear if there's better ways of doing this also, because it's not entirely clean sometimes. So yeah, guess I'm moving on to this, talking about this pipeline, which is a kind of a centralized version of a pipeline I built for some gesture researchers at Red Hand Lab and CC at the University of Oxford. So some of these steps need a GPU, like running. So sorry, to explain what this does. This pipeline is, or maybe I'll skip ahead and show the overview of the pipeline first, actually. So what this pipeline does, the plan is to first download some video files. We're going to download them from YouTube, a bunch of Onion News Network videos, and then we're going to both segment them into shots and run pose estimation with the software called OpenPose. And then as a next step, we do pose tracking, and then from the skeletons, we choose good faces to embed, and then we embed them. And then this runs for each, this is running, let's see, looking for a pointer here. No, just to go annotate. Okay. Well, anyway, Spotlight. That's probably what I want. Okay. Yeah. This is running multiple times for each video, right? So this whole thing runs individually for each video. We do this pose estimation, shot segmenting. So it kind of already comes in put into chunks for us, and hopefully this is a nice sized chunk. So this means it's kind of embarrassingly parallel across just at the video level. If you have a big enough corpus, then that's easily going to be enough parallelism. And then like after this stage, okay, so this pose estimation step and this face embedding step, these want to run with the GPU. Because they run a lot faster with the GPU, but anything else can run on a CPU node. So we can just use a GPU for these steps here, which means it might end up that our job executes faster because it might be that the GPU nodes are oversubscribed, but there are easily enough CPU nodes. And then once we've done all that for those videos, we can join them all. And we can cluster all of them. So what this clustering is, clustering the face embeddings, so that what we'll have at the end is we'll have a bunch of tracked skeletons, but we'll be able to group them by people. And what I'm just going to show you is that I'm just going to dump out the faces for each cluster. But you can do more stuff with that. So the gesture researchers went on and used this to help them target their annotation. So whoops. Okay. I don't know how I annotate clear. Okay. Yep. So let's go back. So yeah, and also, so each step can have different types of requirements. So for example, if you do it for a large corpus, like eventually this clustering stage, so the clustering algorithm I used was RNN DB scan. So this builds a nearest neighbor graph as part of running. So if you have a whole corpus with many videos and therefore many faces and face embeddings, this can take a lot of memory. So you could do this, but you can request like, I just want a high memory node for just this step. So I think it's convenient. Okay, so let's do the kind of start with the mini Snakemake tutorial, which start in the slides, and then
maybe that's
yeah.
a good point. There's a question in the HackMD,
Yes,
which
perfect.
is so regarding the pipeline that you were showing before.
Yeah.
User is asking whether there might be a license violation in downloading the video of YouTube and how from YouTube and how the pipeline
Yeah. So
license issue
yeah,
the
YouTube
account.
DL even got into some trouble, right? I mean, this is for demonstration use. It's not included in the container, so I'm not distributing them. I'm just providing a recipe for how you can use YouTube DL. But yeah, well, there's the problem is that there's not like that much. Yeah, there's not that much. I mean, you can download them and you can use them for personal use. Can you use them for? I'm not exactly sure about the legal implications here. I think a lot of things you are. I don't know. Ask a lawyer, but I'm not redistributing them. So usually that means you're not too far not too far wrong. I'm showing you how you can download them and create derivative works on your own. Don't distribute your derivative works. It's for educational use, okay? So it's all right. Yeah, the problem is in a way like there's not that much like realistic data which is completely openly licensed in terms of this. But anyway, yeah. So here are the YouTube things, YouTube IDs, and you can download these for local use. The law may vary in your jurisdiction, so feel free to consult a lawyer before running this script. But normal Python code can go at the top level. So you see this is normal Python code. We import the path join function, and then it's also Snakemake injects some global variables. So you can pass configuration values with the C flag to Snakemake, and then you can get them like this, and then you can also put a default. So we're just going to put everything in a directory called work in the current directory. But then you can pass an absolute directory there if you want. It provides some customizability to your workflow. So normal Python code can go at the top level. Yep, just what I said. And then here's what a rule looks like. Here's a basic rule, and I'll show some more rules in a moment. This rule is going through all the video IDs and it's saying, hey, I'm gonna output these in the work directory, and I'm gonna output them as the video ID and MP4. So and so you can have multiple files as outputs. It's not a problem in Snakemake. Unlike in a make file, I think usually you can just have one. You know, as soon as anything requires this output file as its input, it's going to make sure that this rule is run so that the output is produced, and then this is going to run YouTube DL, and it's gonna download this, hopefully legally. So rules can have multiple outputs. You can also have comment. You can also put a comment here at the top so you can document them. So here's the output directive. You've got the rule directive here. I should annotate. Okay. Got the rule directive. So each rule has this, and then it has a rule name. Okay. It has an output, and it can have a list as an output, but it can also have a single output, or it can be comma separated. And then it's gonna say how to run the rule, and there's different ways you can run a rule, but one of the ways is shell, which is gonna execute some bash. But you can also have Python and write your rules using Python. And if it's shell, then the rule body is a string, which means you can start to interpolate bits. Like here, where I'm building a space separated list of all the video URLs. And then here, what I'm doing is I'm saying, okay, just save it using the ID. So there's a lot more Snakemake resources. So I just linked some of them here, and also linked to some non-bioinformatics snake files that I find in the wild. But now I'm gonna go back and look at this in a bit more detail. Just the code, just to talk about some. We'll show how this rejoining works, because I think that's kind of important. Okay. Oops. Okay, so here we download the videos, and then we're doing this shot segmentation. And what's interesting here is we can actually run this shot segmentation in another container. I guess I'll skip forward. The order I'm doing this, it's not completely planned out, but let's go back and talk about that later. But you can run rules in containers is the point here. But all this is doing is doing the shot segmenting. So it runs ffprobe, which can segment videos by shots. This runs the scale shop. So this is a bit opaque, but it's going to make a HDF5 from the MP4. So it's going to dump out the skeletons from the video. And then it's going to have another step. So this is all kind of straight line, but it takes in the scenes and the untracked skeletons and joins them. So here's it's going to make sure that these two files are available, because here they're in the input and here in the output. And you see this kind of corresponds to this joining here at the post tracking stage. Okay, and okay, how does it all get joined into the? So this is the slightly like the slightly hairy part. So the way it turns out that by the time you've run this linear part of the pipeline with the shot segment, post estimation, post tracking, choose faces, embed, you have a bunch of files, and you actually want them all to be used as a single kind of corpus. So the way I deal with this is I write out a CSV with the description of all the files in the corpus. So because each video comes with some grouping or shot segmentation, and then it has some faces, and then it has some untracked skeletons, tracked skeletons, and it has a candidate. It has the frames telling you where the face embeddings were extracted from. Okay, and that CSV is made, and it requires the kind of last stages of the previous pipeline to make sure that all the files are actually there when it writes out the description. And then, so this is the kind of, that's the kind of, I found that was the most convenient way to join it, rather than having like a ton of files, like actually at some point just buy out from the Snakemake stuff and keep all the files together in a description of all the a file that's a description of all the files. And then once these are all joined, yeah, well then we run this RNN-DB scan, which uses nearest neighbor descent. So it uses an approximate neighbor algorithm and does all this clustering. Okay, and then as the last stage, we're gonna write out we're gonna say the clusters, and we're gonna show which faces made up the clusters. So we can inspect this and see if it looks right. Okay, so let's talk about, okay, now we have the snake file and we have the thing, but how do we run it in practice? Yes, more questions? Yes.
A question, yeah, in HackMD. So someone is asking, what does a Snakemake bring that a Docker file cannot handle? So by its own, so referring to the script that you were showing a
Yeah.
few seconds ago, what part of that Snakemake script couldn't be done in Docker? What part of the current screen, now previous screen,
Yeah.
we must use a Snakemake for?
So Docker is about getting all your dependents. So the way I use it, I mean, they're just tools. You can use them any way you want. I mean, you could do all sorts of stuff. But the way I use it is that I have all the Docker stuff, prepare all the libraries for the image, and then shove my code there in the image, and shove the snake. I shove the snake, set up the snake file, make sure Snakemake is installed, Python is installed. So the way I do it is that I have one. Well, I prefer to have one Docker image and convert that to an SIF, and it contains all the software that's needed. Then this snake file is really more about. This is really more about. Well. Okay. Let's put it this way. Instead of the snake file, I could write. I could write a README and I could say, okay, here's how you do my pipeline. First, you can go off and download your very legal videos that are all openly licensed, and then you can manually run ffprobe, and I'd have a text file, and you can go in and follow my text file, and you can run that on HPC, and you can even figure out like what type of nodes you need to run each of them on. So I see this as like the Snakemake being like the outer layer. The way I would use Snakemake to build my software is I build the software as many small programs, and then compose them using Snakemake to build a pipeline. So I mean, yeah, for the Snakemake, okay, for the Docker file, the idea is that like uh, software packages or software source code comes in, and out comes my program minus data. Program without data is the output of the Docker file, and that's the image. And then you separate out your data, and then you have the data coming in for your analysis, and the data comes in to the snake file, and out comes like analyzed data out of the Snakemake workflow. I hope that explains. Does that help? Is it possible to run? Yeah. So I think yeah. So actually about Conda specifically and Julia, I think there is some Julia support in. Let's see. I think there is actually some like slightly higher level Julia supported. I mean, you can run anything that you can run using Bash, just fine using Snakemake. But also, it looks like there's some like script support. So this is like an alternative to running stuff using shell. I kind of prefer to structure everything as command line programs and then run them using shell. But also you can have scripts, in which case they can access inputs and outputs from like Snakemake patches like a global Snakemake object into it with snakemake.input and snakemake.output, and then you can inspect the inputs and outputs of your rules and write stuff that way. For looks like Julia, Rust, Python, and R are supported to run stuff that way. And then as far as Conda is concerned, yes, there is some Conda support. So Snakemake has a lot of features, and this is so Snakemake is kind of messy, but also it probably like supports, you know, you can use it in different ways, and this is a good thing and a bad thing, but maybe you find like that this workflow is kind of comfortable for you and a nice way to use it with Julia. Although your Snakemake itself will still be in Python, mixed with Snakemake directives. but it looks, yeah, also snake files can include, they can say, okay, for this rule, here's my like conda environment, and so you can give it a container for this rule, run it in this container using Singularity, or you can give it a conda environment, and for this rule, run it in conda. Yeah. Let's see. Okay. Did I answer the questions? Is it okay? I tried. Okay, I'll move on. Let's see. So where were we? A little bit confused. I think, yeah. So I think we went through the snake file basically, and now we can talk about how we're going to run it. Yeah. So how do you run a Snakemake pipeline on a SLURM cluster? So as the kind of basic support, Snakemake, when you run Snakemake, the Snakemake command, you can pass in like an argument, which is like, will be something like srun. I suppose you would pass in srun, and this is an argument you can pass anything that's like shell to it verbatim. But the problem is that then Snakemake should also be able to tear stuff down if there's a problem. And then it should also be able to check the status of stuff, see if it's died. Maybe it wants to restart it, or maybe if it's died, it wants to tear everything else down, or not run anything. Well, not run it. Well, if something's died, it wants to not run anything new and inform you that one of the steps has died. So instead of passing all that in, you can use this thing called profiles, which is an interesting design by this Snakemake people. So I think this has been through a few iterations as well, the cluster support, and I think there's going to be another iteration, but currently it's still using profiles, and there's one called SLURM profile, which we're going to use kind of indirectly. And it's worth noting that this is like not exactly a plugin system, and these are not Python libraries. There's some stuff that you put in a directory with a configuration file, and then you can put some Python in there too, but it's not, unfortunately, it's not an actual Python package, which would be nice if you could just pip install it, but unfortunately, they didn't go that way. To get SLURM support, pip install SLURM support, Snakemake SLURM, and get SLURM support. So, okay, moving on. How do we containerize Snakemake workflows then? Because we want to put all our code in one container. Maybe I think this is the nicest possible way. I do believe in. Well, I like it when people give me a push button experience to run an analysis. So I believe in like trying to do this if it doesn't mess up everything else, if you can do it reasonably easily. So now we have a Snakemake. Snakemake is a dependency of our project. So we should include it in our container, and we should include also our snake file in a container. But now, we want to use SLURM from our container. But all the SLURM support is really doing is it's calling this command, sbatch, and that's not in your container. That's on the host. You've got, in terms of installed programs, the container and the host are kind of insulated, right? So I came up with a solution to this, which is singreqrun, and it's also SLURM too for using. This is particularly for using Snakemake and SLURM. This SLURM too. So I'll talk about that in a second, but I'll just talk about something some people have done, and apparently some people have made it work, but I think it's a bad solution. So you could just bind sbatch. You could bind this command from the host directly into your container, no problem. Okay, now we need to bind various SLURM libraries. That SLURM has like shared objects that are to do with SLURM. And then, okay, you bind all those libraries. I've tried to do this. And then you find you've got a different version of libc on your host and in your container. So this is bad. This is what we're trying to avoid with containers. We're trying to stop this like dependency library hell and work around it by making a big binary blob of all our programming dependencies, which is, yes, it's a sledgehammer to crack a nut, maybe, but once you accept that that's what you have to do, it can make life easier for you. But yeah, this alternative solution, I think it's bad. I don't think I think it's even worse than my solution. So what's my solution? Is singreqrun is a client. It's got a client and a server, and the client runs inside the Singularity container and requests a command is run on the host, communicating through the file system in a way that I think is safe for all sorts of file systems, but could be wrong. Through a series of named pipes, in fact. Now, I recently updated it, so the client is a statically built C program, so I think this is safe. Reasonably safe. I mean, it assumes you're running on AMD64, but not much else. It's a very portable, statically built C program. It's actually built with a project called Cosmopolitan, so it's linked with its own libc. It doesn't. It only relies on the system call interface. This can be bound into the container in the path. And then the server executor is actually so I said batch script. It's a bash script run on the host, and then there's also this SingSlurm2, which is kind of a package which gives you a kind of convenient way of running this all together, amalgamating this monstrosity. So it arranges for the correct binds, and it arranges for SLURM profile to be used by Snakemake. So you don't have SLURM profile in your container. This is running as part of this SingSlurm out of your container, but then being kind of arranged in a correct way. And yeah, then it arranges for Singularity containers to be started. Right. So maybe I can go and show where this is and what the hell I'm on about. So here we are. Here's the repository, SingSlurm2, and here's the newest release, which is very new, hot off the presses. So how am I going to use this? I'm going to get this link from the release. So I'm just gonna, I have some stuff here already, but I'm gonna move that all into my model answer directory. Okay, so I'm just gonna check this. Control Shift equals. Okay, let's bang with the font size on this a bit. Oh. Okay, hopefully that's legible now. So I will get this release. It's just a zip file, and then I will unzip it. Okay, so what do I have here? I have SingSlurm2, and what am I going to do? I'm gonna try and run this pipeline with a copious reference to my model answer, I'm afraid. But okay, so I'm going to make this directory, and I'm going to make a run thing, a run script, and the run script is going to run. Change it to entry point. It should actually update that. So we can have SIF path. So the SIF path is going to be an SIF that we get from here. So we saw how to download that already. So I'm just gonna, because it takes a while to convert, I'm just gonna copy it in from the model answer. Okay. Oh, in fact, that's not instant. Okay. Okay, and then I'm going to pass in the SIF path here as an environment variable to the script. Okay, and then the rest of the settings. So this is the basic idea. We have this entry point for SingSlurm, which is going to set up everything for us. I'd run our snake file in there. So what are the main environment variables? We've got this SIF path, a snake file, and a cluster config file, which is probably the most, well, they're all important. Those are the compulsory ones. So I'm just going to refer to my model answer here. Okay, so what do we have here? So first, unfortunately, so first what I do is I just put in here the path to SingSlurm. I set this to environment variable, and then I'm going to source this. What is this contrib CSC putti? So some HPC environments, they have some stuff that they set up, and then they might tell you not to run Singularity, to run something like Singularity wrapper. So this CSC putti just saves the equivalent of the Singularity wrapper to an environment variable, so that SingSlurm can run it at the right time. So that's why that's there. And such boilerplate might be needed for different HPC environments. Often there's some boilerplate you have to run to get things working nicely. I think it sets up binds. It mainly just sets up binds for the project workspaces. Actually, that's all it does. So it's just extending the default binds to include Scratch and project directories. And then the snake file. So I will just cheat and find where my snake file is. So this is where the snake file is inside. So the snake file is inside this container now, this SIF container. And then we give it a reference to where the snake file is inside the container. And then there are some other things. So I'm not going to do that sing extra args. Yeah, this cluster config is important. So this is a JSON file, which tells us about the resources we'd like for each step. So you might have noticed that the snake file didn't say that, okay, I want a GPU for this step. You can actually put resources in the snake file, but I prefer a style where you separate that out. So you have a snake file that, like, if you had a single node that had all the right resources, you could just run your snake file with no parallelism on that node, and it might take a long time, but you know it can also run not in HPC, in theory at least. Okay, there's the entry point. Then I set this restart times to 0. So normally Snakemake will restart your job if it doesn't, if it fails. But I don't like this. I want it to just fail because it might have failed because there's a problem with the job. So then you can repair it. Whoops. Yeah, and then the actual arguments to this script get passed through to Snakemake. So this is one of the arguments you can pass to Snakemake is the target script. So I pass all here, which will it will run the whole thing. So let's see. Let's try and run this now. In fact, I'm gonna because this is gonna take a while if I run the whole thing. So I'm gonna copy in some of the files so that it doesn't have to. So I'm going to copy in the video files into the work directory. So now we don't have to download this. Okay, now let's see what happens when we run it. Is it going to work? Right, that's not work, because that's not where I put it. I put it here in my project directory. I didn't put it in my home directory. So I mean, you have to put this SingSlurm package somewhere, but okay. So now it's point store this. Okay. Okay. Oh, right. Whoops. Forgot to make the cluster config. So I don't know. Time's ticking on, so I'm gonna copy that of the model solution and then just show some key parts of it. Nope. Postface cluster c.json. Right. So I'm just gonna copy that in and show you what's in there. So with this default thing, like, will apply to rules by default. It's the default resources you're requesting. So by default, we just request an hour for everything, and 2 CPUs and 1 node and 8 gigabytes of memory. So I mean, we can tune this to if we want to be efficient about this, we can try and, if we have small rules, we can tune it down. It sort of makes sense to start from, like, have a fairly small reservation for your default rule, and then some rules will need more, right? So for this one, I actually asked for less memory because you're just downloading it. But we're not going to run that one, so you don't need very much memory to just run wget. Then dumping skeletons, untracked skeletons. Here we ask for more memory and more CPUs, because this is actually also CPU intensive, this post tracking. And then it's also going to ask for, it's going to run in a GPU partition, and we're going to ask for a GPU. And yeah, this is all very, like, cluster specific, but these all correspond. These just are SLURM directives that's in JSON form, right? But it's nice because it maps to your rules in your Snake file. And then, yeah, for the face selecting, okay, this is maybe a bit greedy. I don't know if we need so much memory, or I think we just need a GPU for this. I don't think we need so much GPU, but we'll just ask for it anyway. Okay. And then actually, we'll not, if this was for a bigger corpus, if this was for a full size corpus, we would ask for a really high memory, like a quarter of a terabyte or something of memory. But as it is, we don't need that much because it's not that big. Okay, so now that's there. Now maybe it will work. Oh, okay. Yeah, there's another thing I'm gonna say, because I'm gonna use Singularity here and hope it works, because I did try this briefly, but I was sort of tweaking it just right up to the before we're starting. So let's hope this works. Let's see. Okay, there's an error in my Snake file where I accidentally set directory where I didn't need to. Okay, so now it's gonna pull the Singularity image here. So I'm gonna talk about what that's all about then. So I thought we already had a Singularity file. Didn't we just build one Singularity file and now we're pulling another one? We've built a Singularity file for our like basically all the code for all our steps and our Snakemake file, and we have one Singularity file, and that's nice because it's all very monolithic and simple, and we can just archive that with all our data or whatever, and now we've done nice fair research. Well, maybe you do need to use more than one Singularity file sometimes. So we might have different versions of libraries and different versions of dependencies, and then we have something that's like really old piece of software that we need to run as a step, one of our pipeline steps anyway. So then we want to pull this in as a separate Singularity container. And Snakemake has its own Singularity support. So this works. So Snakemake Singularity support is not to do with running Snakemake inside a Singularity container at all. It's actually to do with Snakemake running Singularity for a particular, just one rule, or different Singularity containers for different rules. But now we've got the same problem again, that Singularity is on the host, not the container. But hey, we've got singreqrun, so we can just use that again. So this is what it looks like. Just, I don't know, maybe it's kind of cool. It's all just plumbing really, but yeah, I will annotate this spotlight. So we start off here. When we run stuff, we just run singreqrun for the user. That's all that's required. And this starts up this workflow container, which is our big monolithic container containing most of our steps and Snakemake itself. And then Snakemake goes and calls this fake S batch, which is actually the singreqrun client. And then this calls into the executor, which runs the real S batch, which starts a SLURM job. This SLURM job gets another executor, another server, and also, so when the SLURM just started, it starts as this executor and also this the same workflow container, the monolithic container, which actually starts this kind of stub Snakemake job, which calls into fake Singularity, which is a client, which calls into the executor, which runs real Singularity, which runs our job container just for our one Singularity step. Okay. All right. So let's see. Has it done it? No, it has not. Let's see. And it was this step that I just added that. Oh, it was working before. All right, never mind. Let me just quickly see if we can fix this quickly. If not, maybe we can leave it there already. Let's see. Okay, what's happened here? Oh, whoops. Okay, this image doesn't contain bash, so that's no good. Okay, so your Singularity image needs to contain bash. That didn't work because the image that I chose was not a good choice for that. I was trying to demonstrate the Singularity and Singularity, but maybe flew a bit too. So that does work normally, but you know you have to have a. The problem is if you pull a random container from Docker Hub, it might have this really minimal Alpine build which doesn't even have bash. So what I'll do is I'll not run that in the container because I actually have ffprobe in the main one, and then I will show this syncing. So, whoops, maybe, yeah, I will do what I would usually do in this situation. I would create a directory called binds. I would sync my local version of the snake file. So I've made a change locally, but it's not in my image. Whoops. But it's okay because we can just bind over it. Okay. It's almost like I intended it to happen. So then we have the binds in the workflow here. We just copied them over, right? But now this will keep copying if we want to keep hacking our snake file. And that's in GitHub, so you can just copy paste that script if you like it. Then I'm going to, I'm going to change, but now I have to change my running of singreqrun. And I'm going to, again, just take something from my model solution. No, No, don't try. Okay. So you can pass in arguments to Singularity here with this sing extra args. And here I'm just going to bind present working directory workflow snake file and bind it as the snake file with where it expects to find it in the container. Okay. Now let's see if we can get it running. Maybe it'll work. Yeah, you so speak up if you like. I don't know. Someone turn the camera on, and yeah, feel free to. Okay, so here, so here you see it running, and it seems like maybe it'll work this time. So it's got there's 8 videos, so it's running 8 steps of these like more parallelizable bits. It's running these 8 times, and then it's running these things that run for the whole corpus just one time. No, okay, it does seem that there's multiple breakages here, unfortunately. So I think we can probably abandon this in a second. So yeah, so what's happening here is it says there's an error. Sorry, I should narrate this properly because this, I mean, this is mostly when you're doing this stuff, you're dealing with errors, right? So Snakemake will print out these errors, right? And includes, what it does is it doesn't tell you what's happened exactly, but it does give you the cluster job ID here. So then you can use that because SLURM just puts, well, this is just the default behavior that SLURM will put the output in a thing named after the job ID. So then you can cat that out. Okay, so I don't know what happened there. That must be, yeah, that's weird because I was running this before and the tracking works, but I suppose now at some point I've accidentally updated something in my container and the tracking is now broken. So let's abandon this because I can't fix this now live. But I will just wrap up by saying I'm open to questions, and would be really interested to hear about alternative approaches and trade-offs with regards to complexity, because I mean this maybe is growing quite a lot of complexity, and but I think there might still be some wins with this approach, but I'd like to hear some arguments against it to save me from myself, and also, yeah, any perspectives on repeatability and reproducibility. What kind of level do you think about that? So I'll stop sharing now, and maybe people would like to have a discussion about this, but
yes,
if not,
thank you very much. Yeah. Thank you very much for the very interesting talk. Let's give our speaker a virtual round of applause first. I see there's one hand raised from Sabri. So yeah, Sabri, please go ahead.
So during this demonstration, you had several components in addition to containers.
Yeah.
So as a reproducibility or like a repeatability,
Right.
of more parts you have,
Yeah,
more things will break.
I absolutely agree, and this is like, I mean, this is kind of this is what's the annoying thing. In theory, though, like if you have a single node that's really big, that is like the superset of all the resources that you need, so it has a GPU and it has lots of memory, then you can run the Snakemake file without you can just run your container and not use any of the SingSlam stuff. So it's kind of got, but I mean, if you need these things from that are only available in the cluster, then you're like necessarily tied to the cluster. So it does bring into question like, what can you do about this? You can't, yeah. But I mean, also the nice thing is this. I mean, you've kind of decoupled things. You have this JSON file with the cluster configuration, and then you can kind of I have successfully like gone from, and I wanted to show it, but then it turned out that Putti and Mate are not the right type of well, I wanted to do it with the two CSC clusters, but Mate doesn't work like I want, so that wasn't possible. But you can change the cluster configuration file, and for a different cluster.
My question is, let's say you have demonstrated this on Putti. So in ideal world situation,
Yeah.
Reproducibility thing that you give me that one, and I can run it on Lumi or one of
Right,
my front
exactly.
sagas, right? So
That
you
would
have
be
to give me
nice.
something. You give me something, and I run it. So so that is, I think, this container discussion, that is sort of like where it goes wrong. For example, people sell it like snake oil, right? You know, make a container, and it's usable everywhere. It's the it's the way you present it, right? So you have to use the container where it's needed. But if you can, if the Snakemake script that you actually showed, it should actually be more reproducible than if it is combined with the container, in my opinion. I don't know.
Well, so the thing is there's different versions of Snakemake, and it's not entirely backwards compatible. So yeah, maybe not. I mean, maybe you introduce a bug in, or slightly changes the behavior in different versions of Snakemake. I mean, there's so many things that can go wrong when you think about it. I agree with regards to the like overselling of containers. They have been oversold, and I think maybe that's why some people just are like. But I think they can be kind of useful. I would take a kind of apologetic approach and say that they can be kind of part of the solution, but you have to really think about what you're doing with them, and is it worth containerizing anymore? But I mean, I think the thing is like a bunch of companies got into like thing, and then they have to sell it. I mean, Docker was a big company that was trying to sell it, and then Red Hat trying to sell containers. And then now well, Singularity, it started in universities, but then now it's like partially commercial, and they're trying to sell their own version of containers, and it's a bit like they're trying to sell it to managers and force it on people, and I think that's not good. I think it's just a tool.
Yes, there are also a couple of interesting questions in HackMD.
Great.
So the first one, I think, sets a very nice ground for discussion. One question I get during HPC basics teaching is, what is a container actually? And what is the difference of that compared to a module? Not comparable, yes. How can we answer this without using terms like a kernel? Because a person asking the above question would have a hard time understanding what a kernel is.
Yeah, so yeah, well, like, okay, what is the container? So it is comparable to a module. Actually, I think in Mate in CSC. So this is the new cluster in CSC, the national Finnish computing provider. They have implemented they have a policy that all the modules are now going to be implemented using Singularity. So I'm not exactly sure that I think the way that works is that it makes some stub scripts that call it, instead of, you know, they're calling into the container rather than you know, it looks like it's a command on the thing, but actually it's just binding all the directories you might need, and then actually calling into a container. So I think containers contain, what do they contain? I mean, really, it's most important that they contain libraries. and they contain your standard library. So like a container, I mean, if the person knows what a virtual env is, you can say, yeah, it's like a virtual env for your whole operating system, right? It's like a virtual env, but you can contain you can contain C code that's not in PyPy that way. One question, yeah. Yeah. Yeah, I guess so. It's like a virtual env would be if they understand what a virtual env is, or it's like a disk. You could just say it's like a disk image, really. I mean, we are kind of using them a lot of the time, like cheap virtualization, right? So I mean, yeah, it's a bit like virtualization. It's a bit like this. I mean, but how just without analogy to anything else, find out what they've used and find out the closest analogy, because there's a lot of stuff that is container like, because we're always trying to control things by containing them, I think. Do you have any recommendation regarding HPC tutorials or documentations? I don't know. I think Alto. I used the Alto ones a lot when I was getting started, and then Google a lot. Yeah, just Googling but I don't know. I got quite comfortable with this odd way of doing things with Snakemake, but it's not like a fully general approach, and then you have to and then but if you're kind of going into not doing it that way, I mean, you do some bash scripting in your Snakemake, but you kind of seem to get drawn into bash scripting. I've done like loads of bash scripting trying to get this bloody SLURM and singreqrun to work, and drawn for some reason, like HPC has some kind of horrible way of making you do bash scripting. Is it just me? I don't
know. Sabri has the hand raised, so please go ahead.
Yeah, sorry, that question about what is a container, it was a pure selfish question, actually. I have never been able to answer that properly for a newcomer.
Well, maybe you can try to explain to me, and we can try and debug it together. We can try and.
Yes. The thing is, you can say that the operating system, everything except the kernel. Then people ask what a kernel is, right? So
right. Okay. Yeah.
It's like then we say that all the libraries. Then they say, I have my Venv environment, my Conda. It has my libraries. So what is the difference?
Well,
then we'll say that operating system components are included. Like, let's say if there's a software that runs on Ubuntu and we have Red Hat and you can run it, you can bring a center. But then they ask, what is the difference between these two? So it's like a never-ending sort of frustration at some certain points.
Yeah, I mean, I think in practice, like, so the Conda does have so many libraries that I don't know. Do you get different versions of libc in Conda? I haven't used it that much, but I know it contains stuff like CUDA. So I think it must be able to deal with different versions of libc, because CUDA is very fussy about libcs. So I don't know, like Conda's almost at the, except for it's not actually containerized. It's instead it's just like patching library paths or something like that. But
so the libc with Conda is it's become trickier when you have install a lot of things, because if you know in Conda you have, let's say, Python 3.8, then you have a hash afterwards. So that hash is a precompiled version against a certain glibc, for example.
Right. Okay. Yeah.
So then you have to make sure that that precompiled set of things you need in the same Conda environment are there. Otherwise, the Conda will spend a lot of time trying to figure this out and it will fail.
Yeah. I mean, this is my like container building and conversion is slow, but actually when I've tried to use Conda, is even slower. And often it's slowest before it tells you that, oh, whoops, actually I can't resolve these. But yeah, I mean, for some things, like Conda's kind of your only option, I suppose. Yeah, and there's this Mamba too, which is maybe faster. I don't know. I looked at that and I thought, oh, this looks nicer, but it was kind of a little bit premature when I was looking at a little bit. Yeah. I don't know. Should we stop recording? See if anyone wants to talk off the records.
Yeah, I was just about to ask if we have
Okay.
further questions for this part. Okay, so if there are no further questions, thanks again, Frankie, for this very interesting talk.
Thanks.
Let's give again a virtual round of applause. And I will now stop the recording.